Hi everybody, happy Thursday. We're going to go over this proof worksheet step by step because proofs are hard, and we would do it if we were in class together. This looks kind of weird. There's lines but they look dashed. Anyways, so we're trying to prove that triangle LIN is congruent to triangle WIN. And we know we have AAS theorem, SAS postulate, ASA postulate, HL theorem, and SSS postulate. Those are the 5 that we have. So we have to use one of those. We write the given. N is the midpoint of LW, and we talked about what that means, and LI is congruent to IW. So let's mark LI congruent to IW. And then if N is the midpoint of LW, I want to say, who can tell me which segments are congruent? But you can't talk back to me. So which segments are congruent? LN and NW. So LN is congruent to NW by definition of midpoint. The midpoint of a segment is the point that divides a segment into 2 congruent segments. So these are, and then we need one more side. So what other side can we mark so that the triangles be congruent? We can mark IN. IN is congruent to IN. And what would be the reason for that? Reflexive property. And now what method is it for them to be congruent? Side, side, side postulate. And these 2 steps can actually be switched. You can do the reflexive property first and then do the definition of midpoint second. The order of those 2 doesn't matter. The next one says KT is congruent to PT, KT and PT, and angle KAT and angle PAT are right angles. Why do we want them to be right angles? Because we want them to be right triangles. And what's the only method of proving congruent triangles with right triangles? HL theorem. So we have given. And if we use definition of right triangle, triangle KAT and triangle PAT are right triangles, because right triangles are triangles with one right angle, and they have these right angles, KAT and PAT. And then what's the other side we can mark? AT is congruent to AT. And what's that called when you mark the side congruent to itself? Reflexive property. And so it's HL theorem, because we have right triangles, and we have, this is the hypotenuse of the triangles because it's across from the right angle, and this is a leg, hypotenuse leg, and we don't have any way of getting these 2 sides congruent, so it has to be HL. Otherwise it would be SSA, which is a bad word if you say it the other way. So we have that. This one, we have TA is perpendicular to KP. That means it makes a right angle. definition of perpendicular lines gives you right angles. What right angles would it give us? Angle TAK and angle TAP. Perpendicular lines give you right angles, so these are right angles. And then angle K is congruent to angle P. Angle K is congruent to angle P. So because they're right angles, they're congruent to each other. There's something called all right angles are congruent. So angle TAK is congruent to angle TAP. All right angles are congruent. And then TA is congruent to TA using the reflexive property. So can you tell which method this is? It's a right triangle, but it's not HL because we don't have the hypotenuses. It's angle side theorem. And I forgot to write given. The angle side theorem. On number 4, DE is congruent to BE and AE is congruent to CE. DE is congruent to BE and AE is congruent to CE given. And then there's no reason to mark the other sides congruent, so it won't be SSS postulate. But we can get some angles. Does anybody know what kind of angles we can mark? Vertical angles are congruent because they make a V, an X. They make an X. This is angle DEA. DEA is this angle. Congruent to angle, and this is angle BEC. And then what method would it be for them to be congruent? SAS postulate. Two sides and the angle in between the sides. Side, angle, side. Side, angle, side postulate. And then hardest one. So don't worry if you didn't get this one. These are parallel and these are parallel. So these are parallel and these are parallel. And the angles that we get from them are alternate interior angle theorem. And when you look at this, these angles are congruent because they're alternate interior angles. And when you look at this, these angles are congruent because they're alternate interior angles. When you have a zigzag or an X, a Z or an N, you have alternate interior angles. So this angle is angle RUS. Angle RUS is congruent to angle, this one down here. These are alternate interior angles. Angle UST. And then from these parallel lines, we get this angle and this angle. These two. Angle RSU congruent to angle SUT. SUT. Alternate interior angle theorem. Then we need a side, because you can't have just angles. So what side is reflexive property? Side SU. SU is congruent to SU. And then look and see if you can tell why the triangles are congruent. Angle, side, angle, postulate. I think that's the hardest one. It's 2 angles and the side between them. 2 angles and the side between them. Angle, side, angle, postulate. And then on our last one, E is the midpoint of AB. Angle D is congruent to angle C. Given. So we have E is the midpoint of AB, just this one, not the other one. So the 2 segments that are congruent are AE is congruent to EB. AE and EB, definition of midpoint. And it says angle D is congruent to angle C. And then we can mark some angles congruent. Does anybody see any angles that we can mark congruent automatically? How about the vertical angles because of the X? Angle AED is congruent to angle BEC. Vertical angles are congruent. So why are the triangles congruent? It's not ASA because it's not this side. It's AAS. Angle, angle, side theorem. So, today is Thursday. Spring break is next week. So I was thinking that some of you have some stuff you need to do to get caught up on the assignments that I've given since we left school on March 13th. So I'm going to give you some catch-up days, and we're not going to do anything new until after spring break. So enjoy your spring break. I'll write that on Google Classroom for those that need to see it, and I will see you after spring break. Have a good spring break. Happy Easter, all that stuff. So take care of yourself and stay safe.